All right, so 4.7 is a graphs of other trig functions. It says there the graphs of tangent, cotangent, secant, and cosecant functions are also periodic. However, tangent and cotangent will have a shorter cycle or period than the other four functions. We just need to define the graph over some interval with a length of pi. So it's telling us there that tangent is going to have a period of pi. What's a period again? Yeah, the period is how long it takes it to repeat itself. So for tangent and cotangent, they're both going to have a period of pi. What was the period of sine and cosine? It was 2 pi, remember? So this one takes just half as long. And if sine and cosine are both 2 pi, then so are their reciprocals. So secant and cosecant will end up having a period of 2 pi. So tangent and cotangent are the only two that have a period of pi.
Like no matter what?
No, well, of course, now b will change it. We're talking about the parent function, okay? Just like with sine and cosine, we said y equals 2 pi over b. So tangent, instead of being 2 pi over b, would be
Pi over b?
Pi over b. Very good. All right, so it says the graph of y equals tangent of x. It says the graph of the tangent function will complete one full cycle in the interval from 0 to pi. So the period of y equals tangent of theta is equal to pi. However, there is a vertical asymptote at theta equals pi over 2. On what continuous interval can the entire behavior of the function be shown? All right, so here's what we're going to do. Remember our unit circle, correct? And it has those points. We talked about them with sine and cosine. It has, like, at the angle 0, it has, what's its order pair? 1, 0. We had the pi over 2 that had 0, 1. Over here at pi, it had the ordered pair negative 1, 0. And down here at 3 pi over 2, it had the ordered pair 0, negative 1. And then, of course, 2 pi was back over here. Well, we used all of those when we did sine and cosine. But we don't need them all for tangent and cotangent. Now, it does tell us that tangent has a vertical asymptote at pi over 2. Well, that's going to be because, remember, what is tangent in terms of x, y, and r? Y over x. And so if we take the y over x at pi over 2, we get 1 over 0, which is undefined, isn't it? So therefore, we're going to center our graph in between our vertical asymptotes. And so I picked the points for our parent tangent table, our parent function, to be from negative pi over 2 to positive pi over 2. But we're going to use negative pi over 2, negative pi over 4, 0, positive pi over 4, and positive pi over 2. And so I'm going to erase this here real quick, because now when I do this, I'm only going to look at negative pi over 2 that's down here that has that ordered pair 0, negative 1. I'm going to look at negative pi over 4 that has the ordered pair positive square root of 2 over 2, negative square root of 2 over 2. I'm going to check out 0 that has the ordered pair 1, 0. Positive pi over 4, remember, has the ordered pair square root of 2 over 2, square root of 2 over 2. And then positive pi over 2 that has the ordered pair 0, 1. So we're going to use those angles to help us. Remember, tangent, like we said, is y over r. So when I look at negative pi over 2, down here at the bottom, when I take my y, the negative 1, and I put it over r, which is 0, I'm sorry, I said r, didn't I? Tangent's y over x. So when I take the y that's negative 1, and I put it over the x that is 0, what is negative 1 divided by 0?
0.
No. Undefined. You can't have 0 on bottom. So at negative pi over 2, we know that the y value is going to be undefined. Tangent is undefined at that point. Now at negative pi over 4, we had the ordered pair square root of 2 over 2, negative square root of 2 over 2. When I take y over r, so what's negative square root of 2 over 2 over positive square root of 2 over 2? Negative 1. So at negative pi over 4, our tangent is negative 1. At 0, my y is 0, my x is 1. What is tangent? No, it's 0 because 0 is on top this time. That's all right. And then at positive pi over 4, so we have x is square root of 2 over 2, y is square root of 2 over 2. So when I do y over x, what's the square root of 2 over 2 over itself? 1. And then up at pi over 2, my x is 0, my y is 1. When I do y over x, I get 1 over 0, which is undefined. And so there's our parent table we're going to use for tangent. Good question. Well, it told us up in the note part there above it that it's a vertical asymptote. So how do we do a vertical asymptote? Do you remember? It's okay. It's going to be a dashed line. So at negative pi over 2, I'm going to draw in just a dashed line. Negative pi over 4 is going to be at negative 1, 0, 0, pi over 4, 1, and then at pi over 2, we have another vertical asymptote. And so our graph is going to look something like this for one full period. Now, does it repeat itself? Yes. Okay, it's periodic, which is how long it takes to repeat itself. So, therefore, we can keep going using this same pattern. If I do that, this vertical asymptote is going to be in the same location as this one. So remember, just use your pattern to continue. So I can see the next line after the vertical asymptote, we're down at negative 1. And then we're up at 0. And then we go up to 1. And then we have a vertical asymptote. And we can continue. Then we go down to negative 1, up to 0, and I'm out of my graph on that side. So I can draw in the 2, or the 1 full period, and then the half of a period that we were able to graph there. Or I could go backwards. So the blue one that I drew on the right side is now going to be in the same location as the blue one on the left side. So as I go to the left, I can see from the right blue one that I'm up at 1. So I would go up at 1, and then we came down to 0, then we're at negative 1, and then we had an asymptote. And repeat, you're up at 1, down at 0, and I'm out of graph. And so we can just draw in those pieces that we had. So how many full periods did we actually graph up there?
3.
Well, I have the 3 in the middle, and then I have a half on the left and a half on the right, didn't I? So yeah, so we ended up with four full periods total. Are we okay with the pattern?
Are we always gonna? Is it gonna ask you like how many periods can you graph?
Usually not. No, I was just curious, making sure we realize that these two halves do make a whole. All right, so using your graph there, because I'm going to have to scroll down, let's talk about the characteristics. Now for the domain, does it keep going to the left?
Nope.
Well,
Yeah, it can.
yes and no, right? It does because it's periodic, but it has breaks in the graph, doesn't it? Mm-hmm. So this one's going to be kind of like, we're just going to tell where our domain can't be. So our domain, our x's there are angles. So what angles can it not be? Well, this is kind of like when we did the x-intercepts and the maximums and minimums on the sine and cosine, okay? So find one of those vertical asymptotes.
Negative pi over 2.
Okay, doesn't matter which one. So we got a negative pi over 2. And how often are they happening? Well, it's every full period, right? And so how far is a period? Pi. So we're going to add pi times k. Well, remember, k is an element of the integers. Okay, if you write the letter k down, you need to put that notation after it. Yes. Now, remember, we could have picked any of those vertical asymptotes, okay? So we could have picked positive pi over 2. We could have picked 3 pi over 2. We could have picked negative 3 pi over 2. Any of them, but it would be plus pi k. All right, what's my range? Does my graph keep going up?
Yes.
Keep going down? Yes.
Infinity and positive infinity?
So yes, it's negative infinity to positive infinity. All right, x-intercepts. Well, again, there's going to be infinite number of them, isn't there? So my x-intercept, find one of them. Pick one.
Pi.
Okay. We have an x-intercept at pi. Oops. And they're happening every how often?
Pi.
Every period.
Every full period, so plus pi k. And again, so k is an element of the integers. We could have picked any of those x-intercepts to start with, though, okay? And then it would have been plus pi k. Where's my y-intercept?
0, 0.
0, 0. Okay, it told me it had odd symmetry, which means it is symmetric to the origin.
Oh, you have to write a symmetric to origin.
Yes. And where are the asymptotes?
Each side of the periods.
Yeah, they're the places where a domain can't be, right? Now, because it is a vertical asymptote, remember we're going to write it as an equation, and they're always x equals. And then it's just whatever your domain was. So I look up here, and we said our domain was negative pi over 2 plus pi k. All right, and I'm sorry, go ahead.
Show them for calculus next year. Are we going to have to memorize all these tables and stuff? Or will they be given to us?
I think you have to know them. Don't quote me on it, though, for sure. It's been a long time since I taught calculus. All right, so from there, guys, we're just going to do the same exact thing we were doing on sine and cosine. We're just using a different parent table, okay? Oops. Sorry, I don't know why all this stuff is popping up all of a sudden here. Okay. All right, so in example 2, it says we're going to graph y equals negative 2 tangent of x over 2. So we've got our tangent table up above, right? And so is there anything that's going to affect my x's of it?
X over 2.
Yeah, the x is divided by 2 in the equation, so what are we going to do to our x's? Remember, x always does the opposite. Good, so we're going to multiply by 2. All right, so what about my y's? Is there anything up there that's going to affect my y's? Yeah, the negative 2, and that's negative 2 times, so we're going to multiply our y's by negative 2. All right, so what do you want to do first, x or y?
Y.
All right, so if I take my y's, my first y was undefined. What is undefined times negative 2?
Undefined.
Still undefined. All right, then we had negative 1. What's negative 1 times negative 2?
2.
Positive 2. Then we had 0. So what's 0 times negative 2?
2.
And then your next one was 1 times negative 2. And the last one in your parent table up above was undefined times negative 2. Good. Now our x's we're going to multiply by 2. So my first x was 0 times 2, which is, no, I'm sorry, it wasn't 0. My bad. My first x was negative pi over 2 times 2, which is,
Fourth pi.
now remember that's 2 over 1. So it'd be negative 2 pi over 2, which is negative pi. My next x was negative pi over 4 times 2. So negative pi over 2, good. And then my next one is 0 times 2, which is 0. Pi over 4 times 2. It's positive pi over 2. And positive pi over 2 times 2 is positive pi. And now we can graph these. Negative pi. We have a vertical asymptote. Negative pi over 2 is up at 2. 0, 0. Pi over 2, negative 2. And pi has a vertical asymptote. All right, and it asks us, what is our period? So we have two ways to do this. They gave us an equation, so we can use a formula. We could say we know that our period for tangent and cotangent, remember, is what, pi over b? And so for this case, what is my b? Well, it's a little iffy there, right? So, because remember, b is the number in front of the x. But so this could be really written as negative 2 tangent of 1/2 x, right? So my b is 1/2, isn't it? And so we just got to get the 2 off the bottom. So we get 2 pi over 1, which is 2 pi. And we could have,
Can you just look at how, like,
yeah,
between the lines of undefined?
yes, you
Like
can.
that?
That's where I was about to go there. So the other way is, since we already have it graphed, we can look at it. It started at negative pi and it goes to positive pi. We know from negative pi to 0 is pi, and 0 to pi is pi. So if we add those together, we get the 2 pi that way. Okay? All right, and so let's do b. Is there anything that's going to affect my x's?
The 4.
Well, the pi over 4, right?
Yeah.
Yeah, the pi over 4 is going to affect my x's. So what are we going to do? No, the plus 2 won't, because it's not in parentheses with the x. If anything's being added or subtracted and it's going to affect the x, I'll put it in parentheses. That's going to be my d value, not my c value. Okay? So what are we going to do to our x's? Well, it says pi over 4 times x, so we're going to actually divide by the pi over 4, aren't we? But we don't like dividing with fractions, so that means we can just take x and do what? Instead of dividing by pi over 4, multiply by the reciprocal. Yeah, so multiply by 4 over pi. I'm sorry, it's really hard to see right there. So what I wrote was x times 4 over pi. And what are we going to do to our y's? Add 2. All right, so y'all do the x's, I'll do the y's. Or would y'all like to do them together? Together, of course, right? All right, so let's go ahead and, you want to knock out those y's? So make sure you look up at the top at your parent table, okay? So my first y is undefined. What's undefined plus 2? Right. And then it was negative 1 plus 2. 0 plus 2.
2.
1 plus 2. And
Undefined.
undefined plus 2. All right. Now for my x's then. So my first x was negative pi over 2. And you said we're going to multiply that by 4 over pi. Well, my pi's will cancel. So we got what? Negative 4 over 2, which is? Good. Then we had negative pi over 4 times, we said 4 over pi. Well, my pi's cancel, my 4's cancel, so I have negative what? Good. And then I have 0 was my next x, so it's times 4 over pi, which is 0. Well, wait a minute. This is pretty easy because remember we said x's always have the pattern 2. So if it's negative 2, negative 1, 0, what's my next one going to be? 1 and then 2. And we can work them out if you want to make sure. All right, so there's my parent table for one full period. Or not parent, excuse me. This is my table for one full period, so let's graph that. So I got my negative 2, I got my positive 2 asymptotes, I got my 0 up here at 2. Okay, well, these are all labeled where I can do it. There's one we're going to have that's not labeled. I thought it was this one, but I was wrong. All right. Questions over the graph? Either one of these? What is my period of this one?
4.
Good. Negative 2 to positive 2 is 4, right? Or we could have done pi divided by, and my b is pi over 4. So if you multiply top and bottom by the 4 to get rid of that little denominator, you'd have got 4 pi over pi, which is the 4, okay? So either way,